Welcome to lecture series on graph data structure. In today's lecture series, we will discuss about uh, the introduction to graph. So before going into graph data structure, let us have a quick recall on the topics we have discussed earlier. So in the earlier lectures, we have discussed about what is a tree ADT. So when we are discussing about what is tree ADT, we have seen various terminologies in tree data structure, types of trees and tree traversal techniques. Now, let us go to graph data structure. So consider this problem statement. Many would have used a social media platform like Facebook. So Facebook includes albums, events, groups, pages, users, and many more. So here all these things are represented in the form of node, and every relationship between two nodes are represented in the form of edges. So whenever you post a photo or whenever you join a group, a new edge will be created for that particular relationship. So we can uh, we can coin Facebook as a collection of nodes and edges. This is what a graph will look like. Now look at the definition of graph data structure. A graph is a pair of sets which contains vertices and edges. Here V represents the vertices and E represents the edges. So in this graph, 0, 1, 2, 3, 4 are the vertices, and the lines between the vertices are considered as edges. So edge is made of pair of vertices. We can define edge in that way. Now 0, comma 1 is an edge, 0, comma 4 is an edge, and likewise. So these are the various types of graph. Graph is classified into directed and undirected graph, weighted and unweighted graph, cyclic and acyclic graph, and strong connected and disconnected graphs. So if the edge points a direction, it is directed graph, and if they do not, it is undirected graph. Similarly, if weight is mentioned for the, if cost is mentioned for the edge, we call it as weighted graph, and if cost is not mentioned, it is unweighted graph. And if there is a connection between all the vertices, it is strongly connected. And if there is no connection, it is weakly connected. If in a directed graph, uh, the edges form a loop, it is called a cyclic graph. And if they do not, it is acyclic graph. So when we are discussing about tree data structure, we have seen a tree can be represented using array and linked list. Similarly, here a graph can be represented using adjacency matrix and incidence matrix. Now look at the adjacency matrix representation of a graph. Here rows and columns are represented by the vertices, and inside the matrix we have two entries, 0 and 1. For undirected as well as for directed graph, we have only two entries, either 0 or 1. So if there is an edge between two vertices, you will insert 1. If there is no edge, you will enter as 0. However, in case of weighted graph, instead of entering 0 and 1, if there is an edge between two vertices, you will enter the respective cost or the weight, and if there is no edge, you will put 0. Sorry, if there is no edge, you will put infinity, and if there is no self loop, you will put 0. This is for weighted graph. So this is the incidence matrix representation of graph. Unlike adjacency matrix, here rows are represented by vertices and columns are represented by edges. Inside the matrix, we have three entries like 1, -1, and 0. So as we have discussed earlier, 0 for entries that do not have an edge, 1 if there is an edge, and -1 is that if the edge, instead of, if there is an outgoing, if there is an outgoing edge from a particular vertex, you will put 1. If there is an incoming edge, you will put -1. So this is the case with incidence matrix. So now look at the figures displayed. So first one, only the path is established. There is no cost mentioned for the path, so it is an undirected graph. Whereas in the second example, the distance is mentioned for each edge, so it is a weighted graph. These are the various applications of graph. It is used in social media platforms like Facebook, LinkedIn, which Facebook and LinkedIn are implemented using graph. It is also used in Google Maps, web graph, graph theories. Operating system make use of graph data structures, and it is also employed in solving map coloring problem. So these are the various, these are some of the assessment for you to better understand graph data structure. So of these following, which one you consider as true? A graph may contain no edges and many vertices. A graph may contain many edges and no vertices. A graph may contain no edges and no vertices. A graph may contain no vertices and many edges. So explore these assessments, find the answer. These are some of the references. So this is a summary of what we have seen in today's lecture. We have discussed about definition of graph, the concept and components with the help of Facebook. We have seen the type of graph, representation of graph and its application. So in the next lecture, we will discuss with some other topic on graph data structure. Thanks for watching.